Dr. Nardi here, back with another video, and in this video I want to talk about the significance of significance or significance testing and why it's important in research and why you should probably care about it. So let's get started. Generally speaking, how does a test of significance work? Well, let me go ahead and give you the annotated version of it, and I'll kind of walk you through the annotated steps in kind of significance testing. So the first thing we do is we state the null and the alternative hypothesis. So we always have to write out a null, then we write out all alternative hypothesis. We always assume the null is true unless we have more information. So the null is our starting point. So we always start with the null. We assume it's true. Next thing we do, we set our level of significance. Now we decide this as the researcher, as the one conducting the study. What's the level of significance that we are okay with? Or another way to think about this is, what's the probability of making a mistake in rejecting the null hypothesis? And we'll get into more detail, but generally speaking, it's associated with the risks of being wrong. And we'll come back to that. So the next thing you do is you collect your data, and then you'll calculate the differences between the groups. So we usually use SPSS, Jamovi. There's a bunch of different programs you can use, and you have to decide whether the difference between the groups is too great to be due to chance. And as you're doing this, you're going to pick some kind of statistical test. It could be a t-test, it could be an ANOVA, it could be a correlation, it could be a multiple regression. That all depends on your research question. But you use your statistical test, and then you decide to accept or reject your null hypothesis. Now, what is a hypothesis, and what is hypothesis testing? Hypothesis testing allows you to make a decision about the results of your study. We also think about a hypothesis as an educated guess. So we're making a guess here based on previous literature. So you have to go into that literature and read it and kind of see what's been done in the past. And really what hypothesis testing is, and inferential statistics in general, is it allows you to make inferences about your population based on your sample. Remember, a sample is just a subset of a population. And generally speaking, we cannot ask everybody in a population about what they think about a certain topic. So we have to get a sample. So we have to get a small subset of a population and then do our test on that. And your hypothesis, remember, should be falsifiable, and also it should reflect a general problem, statement, or question that motivates your research. So why are you doing this research study? Now, just as a reminder, as I kind of mentioned earlier, the null hypothesis is refers back to the population. It's tested indirectly. We also call this a hypothesis of no difference, or the way we look at it is there's no difference between two groups or between groups. It could be more than two groups. Or there's no relationship between variables. We always assume the null to be true unless we have evidence to believe that the null is false. And this evidence has to be beyond chance. It has to be beyond just random error creeping into our data. Now, the alternative hypothesis, also known as the research hypothesis, it basically, we are trying to see if there is a difference between your samples or between your hypothesis, or I should say your hypothesized means. So again, we want to see if there is a difference. So our research hypothesis states that there is a difference. And remember, it's stated in declarative form. Both of them are. But this one says there is a difference. And we don't really go into it in this video, but you can have direct and indirect hypotheses. But that's more for another video. So let's go back to the topic of significance. Why do we even do significance testing in research? Well, really because we can't be 100% certain about anything in the behavioral sciences, mostly because we're working with people and people are unpredictable. We do our best to try to predict people's behaviors, but we're not the best at it. And also, you cannot ask everybody in a population, so we have a small subset of a population. And sometimes when you sample, you can introduce error. Maybe people who are volunteering for your study are slightly different than the people who don't volunteer for your study. Or maybe you're accidentally, have some kind of sampling bias besides your best efforts. So that introduces error into your study. So there's always error that creeps in. So there's always a chance that we're wrong. There's always a chance. So we're going off probability. That's what we're doing here. And it's really the probability of rejecting a null hypothesis when it's true. And as I mentioned earlier in the video, we set the probability levels. And generally speaking, we set the probability levels between 0.01 and 0.05. Depends on what could go wrong or the risk you're willing to take. So in the medical field, often when you're dealing with people's lives, you want to set it at 0.01. And that's basically saying that if you get a statistically significant result, that you're 99% confident that your results are real. And there's only a 1% chance that you're wrong. In the social sciences, you will usually see 0.05. And that's saying that if you get a statistically significant result, that you're 95% your results are due to systematic differences, and there's only a 5% chance that you are wrong. And by the way, when you see it written out, we usually write it out as P is, and then if it's statistically significant, would be less than 0.05. If P is greater than 0.05, then you would flip that sign around there. But generally speaking, this is how we see it written out in the research. Whenever you think about setting that p-value, you always ask yourself, what's the worst that can happen? So what's the severity in the consequences when a mistake is made? If somebody is going to die, you want to probably set it at 0.01. If you're not worried about people dying and there's no lives on the line, then you could set it at 0.05. Now there's a trade-off though, because if you set it at 0.01, your study might lack statistical power. And what that means is the study's ability to detect differences between groups when they exist. However, if you raise it, you'll have more power, but then you're at more risk of making a type 1 error. Depending on how you set your p-value, you're going to risk making a type 1 or type 2 error. One of these errors will happen. It just depends on the consequences of being wrong. And it could be no error, but there's always a chance. Now, here is something I want to talk about, at least go into a little more detail about type 1 and type 2 error. So a correct decision would be the null hypothesis is true and it's accepted. That's a great decision. If the null hypothesis is false and it's rejected, that's also a correct decision. But sometimes we make incorrect decisions. One type of incorrect decision is called a type 1 error. That's when the null hypothesis is true and it's rejected. Or in other words, there really isn't anything going on, but you decide that there is. And the type 2 error is the null hypothesis is false and it's accepted. There really is something going on, but you decide that there isn't. And here's a little graph for those who like visual things. You could see right here that you have your correct decision. You have two correct decisions, right? Reality says the null hypothesis is true and it's true, or the reality says the alternative hypothesis is true, and you as a researcher say that alternative hypothesis is true. But on this chart, you see the error. Now, type 1 errors often also referred to as alpha. You can see that sad face right there in the bottom left box. Or if you look at the top right box, you'll see type 2 error, also known as beta or power. Now, it's a trade-off. If you want to protect more against type 1, you will give up some power. If you want to have more power, you're going to have a bigger chance of making a type 1 error. Now, let me give you another analogy that often helps students. Let's say that you're in court and you're serving in a jury. A type 1 error would be rejecting a null hypothesis or a not guilty when it's true, or convicting an innocent person. So a type 1 error would be putting an innocent person in jail. A type 2 error would be failing to reject a null hypothesis when it's false, or not convicting a defendant who in fact committed murder. So our legal system in the United States errs on the side of not convicting innocent people. So we here in the United States believe a greater injustice is done if an innocent person is convicted than if a criminal goes free. So if you ever serve on a jury, you're explicitly instructed to convict the defendant, in this case the null hypothesis, only if convinced beyond a reasonable doubt. We as researchers are more willing to make a type 2 error, or letting a murderer go free, than convicting an innocent person, which would be a type 1 error. So always keep that in mind, that we want to protect innocent people from going to jail, so we want to protect type 1 error, if you want to think about that one. One last thing I'll leave you with this video is a study can be significant but not meaningful. So for example, let's say I give a stats test to 10,000 students and I get an average score of 75.6, and then I give them a 3-hour review and I give them the same test to 10,000 students with an average score of 75.7. Now, let's say I get a statistically significant difference from 75.6 to 75.7. Does that 0.1 increase really matter? Is it really meaningful? Probably not. And there's actually statistical tests you can do to look for meaningfulness. But that's it for me in this video. Stay tuned for another video, and I'll see you all next time. Take care. Bye for now.